So hopefully I don't spend too much time going over what Jaffer did and kind of reiterate his concepts in just a slightly different way. We're going to be covering a lot of the same things, but just from a slightly different approach. So about me real quick, I am a senior UI engineer at Netflix. And like Jaffer pointed out, we do a lot of RX stuff. We do a lot of RX stuff with Java. We do a lot of RX programming with Groovy. And of course, we do a lot of RX stuff with JavaScript. I'm also known as Bittersweet Ryan, pretty much everywhere on the internet. So follow me on Twitter if you like to talk about JavaScript. Check out my GitHub page if you want to see some of the stuff I've worked on. And before I begin, I just want to start off with a real quick public service announcement. And that's to be kind to those of us with OCD. So does this picture make anyone else squirm? Raise your hand. All right, good. So you'll understand this next slide then. And that's please change your Dropbox icons to the black and white icon. All right. If you suffer from OCD and are talking to someone that has that blue icon, we won't hear anything you say. All we're going to do is look at that icon. So this right here will make us much happier, and we'll actually be able to listen to you. All right, so when we're talking about reactive JavaScript, it's built highly on top of functional programming. So I want to make sure that we all have a very solid understanding of a lot of the functional concepts that we're going to use to build upon to create these nice functional observable streams. So the first one I want to talk about, I'm going to talk about the map function, the filter function, the reduce function, and a function called zip. So again, the map function, when we think of the map function, we're actually thinking of data transformation, right? We're taking a collection of objects, passing them into a projection function, one item at a time, and turning it into something else. But we're not actually going to change our original collection. So here we're just going to create a new set, a new collection, that's going to take a key up collection and change it into something else. So this map function is going to take every key that's pressed and turn that into an AJAX request that's going to return another observable of JSON results. The next function I want to talk about is filter, and that's going to kind of narrow a collection down. So we're going to expand upon that search result sets here, and we're going to make sure that we only want to take get search result sets if their input is 1 character or greater. So we don't want to go and search a huge data set for just A's, right? We want to make sure it's a little bit more specific. So we want to check for A, B, or something like that. And then we can just take that and turn those key presses again into that JSON data. Now reduce is a real interesting one. It basically is going to take a collection and kind of turn it into a single value. So here we have a variable called HTML that's going to be equal to the reduction of that search results sets function. And so this projection function we pass into search results sets is going to get 2 arguments passed into it, previous and current. That previous argument is going to be whatever that function returns. And the current value is going to be the next item in that collection. So here we're just taking that search result sets, so a list of values, and turning it into a single string of HTML that later on we can probably insert into the DOM or something like that. The next one I want to talk about is zip. And zip's really a hard one to wrap your mind around at first because you don't really see the usefulness of it. But when you start doing a lot of reactive programming, you'll notice that you get a lot of lists of data that aren't always connected. And a lot of times you want to connect those and turn them into a single value. So in this example here, we have an array of movies and another collection that's an array of box arts for those movies. But right now they're not actually synchronized, right? We have these just two different arrays. So using the zip function, we can take these 2 arrays and zip them together to combine them into a single data structure that we can actually use. So here we're going to say with art observable.zip, and we're going to pass in both of our arrays. And what the zip function is going to do is iterate through those arrays at the same index and pull that out. So it's going to give you Super Troopers and that first value in box arts, and then we're going to combine them into a new object that's going to have the title and box art. And so when we do that, you see down at the bottom here, we get an array of objects that have the title and box art associated in a single object. Now, observable data streams are a little bit different than doing map, reduce, and filter on an object like an array. In Observable, I kind of like to think of these data streams like a crazy straw, right? You put a crazy straw in a cup of milk, and you suck it up, and it kind of twists and turns through the crazy straw until you're drinking your milk. So in this example here at the bottom, our cup of milk is going to be a key press observable. And it's going to start pushing data up this straw. As it does, it's going to take a twist and turn, and we're going to start doing things to that data. Right? So first we're going to throttle it. Then we're going to filter it out just to get longer search results. So as it travels up the straw, it's changing every time. Then we're going to map through those key results to probably get some type of AJAX data from them. Then we're going to call that distinct until change, so we'll make sure that we're only pushing data once it changes into the stream. Then we can reduce it into a single HTML structure. But none of these are actually going to get called until we actually start for eaching through that data. So when you build up your compostable data stream in an observable, it's just going to sit there until some data actually gets called from it or pushed into it. Then all those functions are going to run at once. So thinking in a functional manner is another very important part of reactive programming. And there's a lot of, it's a big transition going from old imperative style programming to actual functional style programming. So the first thing I want to ask you to do when you're writing functional code is to replace your loops with the functional functions map, reduce, and filter. Because a lot of what you can do in a loop actually should be inside of a map or something like that. So here we're going to have our search results, which is going to be an observable of AJAX requests. And what we really want to do is actually take those, so it's going to be an array of first name and last names. And what we want to do is take those names and combine them together into an array of names that is the first name combined with the last name. So here's one way to do it. We could get this search results observable and then start for eaching over them. And then inside of our for each, we're going to use our old style imperative array to loop through those and create that new array. But we got a lot of state in here. We're creating a new variable and we're pushing to it. So it's not really the best way to do it functionally. So a better way would be to replace that loop with a map a little bit higher up in the data stream. So now we're going to get those search results. We're going to take each one of those AJAX requests and map it into a first name plus last name. Then when we're going to, for each of those search results, each thing getting passed into that, our projection function is actually going to be first name and last name. So the second thing I want to talk about is replace if statements with filters. So a good example of this is when you're listening for key presses, right? If you want to just do something on the enter key. So here we're just going to create a new observable from key presses, and then we're going to do our for each. And inside of that for each, we're going to say if e.which is the enter key. Then we're going to do something with that data. So a more functional way to look at that problem is using filter, and we're going to create a variable called interpresses. So our variable is going to be a little bit more specific to what we're trying to accomplish. And we're just going to do the same thing. We're going to say o.fromEvent key ups, and then we're going to filter out only our key presses, or our enter keys. Then we can loop through those interpresses and do only the thing that we want to do for interpresses in this particular for each loop. Another thing that you can get caught up in doing when you're writing reactive JavaScript or functional programming is create this huge stream with map, filters, reduce, throttles, and you're trying to do a ton of stuff in a single stream. When really what you want to do is try to kind of break these things up into two different streams. So here, if you look down at that filter function, we're actually going to do, we're trying to create a stream that does something for both enter keys and escape keys. So a better way to think about this particular problem here is to break that up into two different streams. So here we have our throttle and map just like we had before, but we're going to create two new streams, an inter stream that's going to be only for inter presses, an escape stream that's only going to be for escape key presses. So like Jeff had mentioned before, flattening patterns is a very important part of reactive JavaScript. So once we get these data streams composed of observables, or in a lot of cases we're going to have observables with nested observables in them, we got to take that nested structure and build it out into a flat structure. And that's where flattening patterns come in. That's also how we manage concurrency and asynchronous requests in observable streams. So let's take a look at key presses. Right? So the key presses, an observable of key presses, is just a list of key presses over a period of time. So you can think of that timeline on the bottom as actually being an observable object. And if someone's trying to search Netflix for the movie Breaking Bad, every time they type a key, it's going to add that data to our observable. But so it's not always perfect, right? Because what if they have a typo in that? They start typing Breaking Bad, but they hit a J instead of an I. They're going to hit the back key, then they're going to hit the I. And where this gets interesting is when we take those key presses and start turning those into AJAX requests. So down here again, our timeline is an observable, but inside of that observable, we have all these other observables that are AJAX requests. And if you look at the problem here, this fourth request is actually going to come in before that third request. We want to make sure that the user never sees that third request once this fourth one comes in. So reactive JavaScript gives us 3 different types of flattening patterns that we can use to accomplish just about any type of concurrency or solve any type of problem we have. So the first one is going to be the merge function. The second one is going to be Concat. And the third one is going to be SwitchLatest. So merge, like Jaffer showed you before, it's going to actually combine each item in collections as they arrive. So if we have nested collections, when one of those nested collections has a piece of data, it's just going to throw it into that observable, or the outer one. Concat is going to combine entire collections at a time. So if we have an observable of observable collections, it's going to wait till the first one is done setting data before it starts grabbing data from the second one and the third one. And SwitchLatest is actually going to switch to the latest collection that arrives in a nested observable structure. So here's a quick visualization of how merge works. So here we have this purple bar at the bottom represents an observable, and these other colored bars inside of it represent nested observables inside of that. So as time goes by, our first observable is going to hit, and it's going to put the data in that structure. And since we're merging them together, when the second one comes, it's going to put that one in the structure out of order. So this green bar here request was actually sent out before that third one, but the data arrived in the third one first. So since we're merging it, it gets put in the observable next, then our third one, and then our fourth one. So here's a little bit more concrete example I have. Let me open up Chrome, put it on the other screen. All right, let's see if I can navigate this while I'm turned around. Okay, so we just want so here's our JavaScript. Basically, we're taking an observable of vegetables and an observable of fruits up here. And the important part is that very last line right here. We're going to say fruits.concat. Actually, I want the merge example first. Sorry about that. Okay, so here we're going to say fruits.merge veggies, and then we're going to for each over them. So what we're going to get is the fruits is going to send off a data of a fruit in a random interval, and the veggies is going to fire an event at a random interval. And so when we actually go ahead and run this code, you'll see that we get our fruits mixed in with our veggies when this observable starts emitting data. So apple, tomato, banana, carrot, pepper. So it's very random, right? We got fruits intermixed with veggies. So now let's talk about Concat. So what Concat's going to do is it's going to add elements or data to that outer observable that you want to flatten it to in the order they were created. So in this case, data is going to come in first. Then that second one's going to come in, and it's going to actually add that data. The animation actually didn't run properly, but the second one is going to come in and add it to that stream. Then the third one is going to go in order, then the last one. So let's look at that example up here again. I can't find my mouse. Okay, so the important part here is that we're actually using fruits.concat instead of merge. And we run this code here, you see that we get all of our fruits before all of our vegetables. So Concat is going to put them in the order that you add them. There's my animation that I wanted. Great. Okay, so the last one I want to talk about is SwitchLatest. And what SwitchLatest is going to do is actually change the observable that's in that outer observable as data comes in. So when our first one hits, the data is going to be the data from our first observable. Then it's going to come along and our second one's going to hit. And it's going to add that data to our observable, and it's just going to forget about the second one because we're switching to the latest data we want. Then when the third one comes in, it's going to go ahead and add that third one to our outer observable. All right, so now what I want to do is kind of take Jaffer's example of an autocomplete and actually build upon that and kind of build something that's what we call an animated autocomplete. So at Netflix, on certain consoles, we have an autocomplete that looks a little bit like this. So when a user starts typing, data comes in from the right-hand side as it comes in from an AJAX request. Then as they keep typing, the next result will fade out, the next one will fade in. And that's a really tricky thing to actually synchronize here because AJAX requests are coming in at different intervals. And if you have an AJAX request that comes in while the results are animating in, you don't want that animate just to pop right off and the other one to come in. You want to make sure those animations actually complete in the order they were given or in the order they were added. Otherwise, the user is going to have a bad experience and it's going to seem real jumpy. So I like to think of an autocomplete as a real simple widget with a real high amount of complexity, right? So we got to respond to key presses. For each key press, we're going to send off an AJAX request. For each key press, we're also going to need to animate out when old search results become invalid. And we need to animate in when new search results come in. And again, we need to make sure that we're only showing them the most current search that they had. And lastly, we got to make sure one animation is completely finished before we start another animation. So let's build this out. So the first thing we need to do is listen for those key ups. So we're going to create a new observable from every time the user hits a key inside of our search thing, our search input. Then what we're going to need to do, again, is transfer those search results into AJAX requests. So here we're just going to take those search result sets. We're going to filter them, make sure that the user has entered more than one key press. And we're going to take those key presses and map them into the data we actually want to do something with, which is data returned from our search API. And again, the important part to notice down here is SwitchLatest. So we're always going to only get and display the latest data that comes in from those AJAX requests. Now this is where it gets interesting, because now we got to take those AJAX results and start animating things. And we need to make sure that those animations are going to be in the right order. So the first thing we're going to do is actually create two new observables, one for key ups. So every time the user hits an additional key, we're going to invalidate the old results. And so all we're going to do there is return a new observable called animateOut that's going to take a div and animate it off the screen. And we're going to create another observable called animateIns. And that's going to take the search result sets. So those are the results from your AJAX request. and it's going to map them and do two different things. So first, it's going to create a new observable that's going to take the actual data from the search results and add it to that new observable, and is also going to concatenate and animate in observable with that. So when we do this, because an animation really doesn't have any data to add to the stream, we need to make sure that when we return this out of the map function, we still have our search results. So when we listen to that stream, we can pull the data out of that to add them to the UI. And these first 4 lines are all we really need to do to make sure that all of this happens in the right order. And that's kind of the real powerful part of observables, right? So we're going to take the animate outs, and we're going to merge them with animate ins, because we don't really care what order they happen. If we have 2 animate outs at the same time, one's going to already be off the screen, so you're not going to see that twice in a row. If we have 2 animate ins in a row, we do want to make sure they complete, and that's where this concat all comes in. So now we're just going to add them to the outer observable in the order they come in, but by concatenating them all, we make sure that they happen one after the other, so we don't have janky fly-ins and fly-outs. And the last part of it, all we have to do is take that combined observable, and now we start for-eaching over them. So this is where you can kind of break out of the functional programming and start doing some imperative programming. So at Netflix, we try to only manipulate the DOM inside of a for-each statement. So we don't try to do any type of DOM manipulation or anything like that inside of a map or filter or reduce or anything like that. It's always at the end of a data stream. So all we're going to do is for-each it, and then we're going to hide it if there are no results there. Otherwise, we're just going to set the inner HTML of that div, or our fly-in. And if you put all that together, it's not a whole lot of code. Some of these observable data streams do get a little bit longer because you are creating short snippets of code. Your code line length is really short when you're doing these. But that's not a ton of code for an autocomplete, especially considering how much concurrency we have to manage there. All right, and that's all I have. If you do have any questions, you want to talk to me more about Reactive JavaScript, you want to get together and hack on Reactive JavaScript, I am Anklam at netflix.com, and I also am on Twitter again at Bittersweet Ryan. And if you want to come talk to me about what we're doing at Netflix, we're doing some really neat things with JavaScript these days. So if you want to talk to me and find out what we're doing and get a little bit more information about that, that'd be great. Does anyone have any?